Okay, question 16. In this question, A1 until A100 and B1 until B100 and C1 until C100 are three sequences of integers such that AN is less than or equal to BN plus CN for each n. Alright, so A is always less than or equal to the sum of the other two, which of the following statements must be true. Okay, so when you see the words must be true, the first thing which pops to your brain should be counterexamples, right? You should try to construct counterexamples. Okay, so let's see. So option 1, minimum of A is less than or equal to minimum of B plus minimum of C. Okay, so how can I somehow make an example where option 1 is wrong? So I can do this. For example, imagine this is my A column, B column, and my C column, okay? I'm gonna pick this. Right, now this is allowed, right? A is less than or equal to B plus C. This is true, right? Okay, so the minimum of A is 3, right? The minimum of A is 3, and then how about the minimum of B? Minimum of B is 1, and the minimum of C is also 1, right? So 3 is bigger than 1 plus 1, which is 2, so 1 is false, right? I found a counterexample, right? So basically, if you find anything where the minimum of A is not made up of the minimum of B and minimum of C, then you're pretty much good to go. Yeah. Okay, good. Question 2, option 2. Minimum of that is greater or equal to, so equality goes the other way around. And again, I think that's not very correct either, right? Because you can just go, can't erase stuff for some reason. You can just go A's are zeros, right? 0 is less than or equal to 1 plus 2. I'm not violating anything. And then option 2 will be wrong, right? It's a perfectly valid counterexample of this. Yeah, because 0 is not greater or equal to 1 plus 1. Right? Okay, how about 3? Think of a counterexample. Okay, so you might realize that, well, you can't really find a counterexample, right? Okay, so when you realize you can't find a counterexample, then you might want to try to prove it. Right? Might want to try to prove it. Okay, so simple proof. Well, without laws of generality, let's say the maximum occurs at A47, okay, random number I picked. All right, doesn't matter at all. Okay, so A47 is less than or equal to B47 plus C47, yeah? And this must be less than or equal to the maximum of the B's plus the maximum of the C's, right? Because, B47 is within the B collection, and C47 is also within the C collection. Yeah, so each of them, respectively, would be less than or equal to their maxima. Yeah. Okay, and I assume that A47 was the maximum of A. Right. So therefore, statement 3 is proved. Yeah, this works for any A you pick, not only 47, but whatever number you like. All right. So answer 3 only, D.